Thank you for joining us. This session is to discuss the online and part-time graduate programs in systems engineering offered through the Whiting School of Engineering at Johns Hopkins University. My name is Cheryl Williams. I am the Assistant Director for Recruitment and Marketing for the Whiting School of Engineering. To give us more information on systems engineering, I have with me our Vice Chair, Dr. Dave Flanagan.
I am a instructor here at Johns Hopkins University, as well as a former student. So I can definitely give a lot of good guidance in terms of how what it takes as a student to be able to go through the program. Okay, so next slide, please. So the things to know about our system engineering program here is that and we have a lot to be proud of. So the first one is we're ABET accredited, so we're actually the first civilian university to have ABET accreditation, and what that really means is that if you have a undergraduate degree from an ABET accredited university, generally this is an engineering degree, then you would also receive a ABET accredited master's program. So it's Master Systems Engineering. If you are not, like me, I was a physics major for my undergraduates, you would be just a Master of Science instead of Master of Science Engineering. And so, but right now our programs are the same, so there's no extra classes between the Master of Science and Master of Science in Engineering for that. And we're also the largest master's program to have ABET accreditation. The only two that we know of right now are two government organizations. Our enrollment, it's roughly about 1/3 on-site live here in the Washington D.C. area, 1/3 online, and then also 1/3 partnerships. And these are typically our other companies that we work closely with, and that's only for those companies that we're actually working with and have dedicated classes. Again, they're all the same materials, same classes, and really Raytheon is one of our larger partnerships for them. And again, the program is available, like I said, a Master of Science or Master of Science in Engineering. That's a 10-credit course. For those that do not want to go for the entire master's, maybe you already have one, there's a graduate certificate, that's 6 classes, a postmaster certificate, that's really 4 classes for there. So again, what we're really looking for is 10 classes within about 5 years. So that's a comfortable pace to be able to go through classes from one a semester, maybe the fall or the spring. You also have the summer as well. But again, that's what we're trying to shoot for in terms of about a 5-year limit. And the reason why we do this is that we have generally we're refreshing a lot of the classes, and so we're trying to stay current. And you go exceed that by a lot, of time, then your courses kind of lose their relevancy for that and the materials. And so that's why we're trying to look for a 5-year. There are some exceptions if you need to kind of push that out another semester or two. We can work with you. And then again, so it's a 1-year work experience. We'll also talk about this in admissions later on. And really because of the reason why is because it's a practitioner-based program. So it's a lot of experience. And so when you're able to come in with some good requirements or tests or architectures, we can actually canvas the entire classroom and rely on their, your peers' experience as well as the instructors. So that's really where we're looking at least 1 year prior work experience as a requirement. And again, it's all dependent on who you are, and we can work with you on that. If you're in the local area, in the Washington D.C. area, we have on-site courses, both at the Applied Physics Lab, that's where the majority of our classes, and a subset of those are down at the Southern Maryland Higher Education Center. That's by the Naval Air Station in Patuxent River in Southern Maryland. Okay, next slide. So with our faculty, we've got a wide variety of instructors. It's one of the larger programs in the EP program. We've got about at least 90 instructors and a lot of backgrounds from where we come from. Most of them, or I guess the majority of them, come from the Applied Physics Laboratory, but not exclusively. And so that's actually good that we're able to have working professionals be your instructor, so they can tell you, their lessons learned, their sea stories, their experiences, and we're able to share that within the classes, as well as using the peers, your peers, the rest of the students in the class to be able to also share the experiences. Just as an example, from the Applied Physics Laboratory, we've got different backgrounds to include, healthcare. So you may have seen on the national news here our prosthetic limbs, and these are, actually controlled by the brain to be able to move these prosthetic limbs. A lot of work with our spacecraft. If you saw that a couple years ago, New Horizons satellite that flew by Pluto, that was built at APL and managed by APL along with other partners. And then also with the Department of Defense, did a lot of work with counter improvised explosive devices, trying to jam them to protect our troops. So, and that's just a subset of what the Applied Physics Lab has to offer in terms of instructors. And the other 35%, equally as talented, coming from private industry, the military, governments, healthcare. So a lot of good things to come out of our faculty. And as you can see, we're not new kids there. The working experience and the teaching experience you can see on the bottom. So generally, a lot of instructors will have a lot of experience going into it. Okay, next slide. So this is our degree program. Like I said, 10 courses, generally over 5 years. Really, it's set up with the core classes. There's some electives, and then you either finish with either the project or the thesis. So we'll go through all of this just to be able to help to describe what this is in terms of the degree there. Okay. So our core classes, our 6 required courses, are listed here. So the first 2 classes are really the prerequisites for any incoming student. So that really gives you the foundation. Our introduction to systems engineering goes through the entire life cycle, although that at a shallower depth, to kind of give you the lay of the land of what systems engineering does. Equally linked up to that is management of systems project. Kind of think about it as introduction to project management. And we do a lot of system engineering and project management together. And so we're fairly intertwined with our sister group, our program with technical management. The third class is software systems engineering. We've made this a required course for everyone because we recognize that you definitely need a lot of software that's resident in a lot of the high technology systems today. So we wanted to call that out and make that a requirement for all of our students going through the program. And finally, the last 3 courses are finish up with our core classes. So this goes back to the entire life cycle and looks at it in a lot deeper depth. So system conceptual design, this is the class that I teach primarily. This starts at the beginning with the initial requirements, concepts, initial architecture. Then you transition to the design and integration once you have some sort of design. And the pieces, how do you stick them together? How do you integrate them together to go from components to subsystems to a full system? And finally, at the end, before you send it out to the field for use, you have to do a lot of testing, to make sure it actually works as advertised and meets all the requirements. So that's our last class, our system test and evaluation. So that's our 6 required classes for our program. Okay, next slide. Our tracks, and these are loosely kind of based in terms of what kind of electives can be used for our program. And again, you can kind of think of this as here's a sampling of what you'd like to be able to do. So if you want to do something like cybersecurity, we've got a series of courses that could be recommended for your electives. Some of them are going to be in the system engineering program, but most of these, like cybersecurity, are going to be in the cybersecurity program. And that's actually okay because it gives you a different perspective on different experiences and different sets of instructors. And this, there are some that are a little bit more technical and more kind of math intensive. Cybersecurity, I think, is going to be one of them. Our human systems, that's one of our newer ones, in trying to look at how the human and the interactions. A lot of interesting work going on in that track. Our modeling and simulation, and again, that's been around for a while. Folks that want to be able to do a lot of simulation, a lot of analysis, a lot of analysis techniques. This is your track for that. Project management is another one that we've had from the very beginning, and that's a little bit closer to our technical management program. And then to be able to take a lot of either group or line or project type management sessions there. Software again, as I mentioned, it was really important. So this is a little bit more on the detailed in terms of software engineering, potentially a little bit of coding. Those are some options for the classes. And finally, the last one is the systems track. And so this is a little broader for other systems engineering type classes. We're starting our new model-based systems engineering classes this spring. We're pretty excited about that because that's something that we've seen from out in the field, out in the industry, that are really looking to be able to represent the needs of the community, the system engineering community, within our course and within our program. Okay. And so finally, capping it off, it's our master's project or thesis. So this is one or the other. So the project is typically about 90 to 95% of students will take this. And these are both self-paced programs. So one semester, you pick a mentor, and we have a stable of mentors to be able to help guide you through. You pick your own project, and you go through the entire life cycle, and you build these project artifacts. So these are requirements, these are architectures, these are trade studies, these are test plans, specifications, schedules, risks. So everything that you're going to learn from those core classes, you're going to be doing, and you're going to be doing by yourself. And this is just a single class. There is no real formal classes. So this is a little different than the other 9 classes. You set your own pace, you set your own schedule, you report to yourself, you give your mentor the artifacts, they can review it, give you a little feedback, but yeah, it's an independent effort. And then the final report, and then the final presentation, it's about an hour presentation, talking about what you've done. So it's pretty intensive, but we feel that a lot of students can do this in one semester. The thesis is another option, and again, less popular, but this is also thinking about, if you're thinking about doing a PhD at one point, or a doctorate program, this gives you a little taste of what it's like to be able to go through that. So you build a committee just like you would as a doctorate student. You propose some research, do your literature review, you have your hypothesis, you're going to build, actually, do some research in itself. Typically, our modeling and simulation track has the thesis, because you're actually generating data, you're building simulations, and you're producing all of that. And typically, what you'd want to do at the end is have some product or paper that's of sufficient quality to be in some of the peer-reviewed either journals or conferences. So that's generally where we have it for the thesis. So note that the thesis is 2 semesters, the project is 1. So if you recall, you have the 6 core classes, 6 plus either 1 or 2 semesters, and then you have the remainder as your electives. So if you took the project, you have 3 electives. If you took the thesis, you'd have 2 electives. Uh, both will get you out into the same end goal, either a MS or an MSE in systems engineering. Okay, so this is just an example program from one of the students. So our 6 core classes, and then some of our other classes. In this case, the example has the student doing the master's project, and then you can look at several different classes here. Metrics modeling and simulation, deployed systems, that's actually systems that are out in the field right now. And that was actually based on some of our workings with the military and the Naval Air Station down in Southern Maryland. And they say, hey, we need this new course to be able to look at systems engineering while you're operating systems instead of traditionally system engineering before you build something. And enterprise systems engineering, that's another one of our advanced courses trying to look at the concepts for the enterprise. Okay, so that's our system track.
So we just want to take a little bit of time and talk about the application process for this program. Your application, the completed application, has 3 components. The first is an online application, and you can complete that online application by visiting this URL right here, ep.jhu.edu/apply. And then in addition to that online application, we'll need your academic transcripts and your professional resume. Your academic transcript should include all transcripts for any coursework that you completed while completing your bachelor's degree. So for example, if you started at a community college and then transferred in that credit into your bachelor's, we'll need transcripts from both institutions. And instructions on where to submit these documents can be found just above the application form at this URL. Dave, do you want to talk about the admissions requirements for your program?
Sure. So I do all the admissions for the systems engineering program, and so on our website, in this slide, this is our kind of minimum requirements. So obviously a bachelor's degree. Ideally, this should be a science or engineering degree, but not required. And again, we talked a little bit about the ABET accredited. So again, that's just based on your undergraduate program and your degree there. The GPA, ideally, you'd like to have it 3.0 or above. And then again, with the 1 or more years of relevant work experience, as already described. So as you can see here, and then no GRE scores there, unlike some other programs. So as you can see here, there's kind of a sliding scale here. So if you're an experienced professional that's got lots of work, experience, but your GPA may not be as higher, sometimes that'll balance out. So generally, we'll try to look for that. If you're sort of a newer student, kind of younger, kind of more out of school, probably going to look more at the grades because you don't have a whole lot of work experience. Now I know there's some companies that we start to work with that require that all entering employees immediately enroll in a master's program. So there are some of them that we have some relationships with that we can work with to be able to help kind of meet both of these requirements here to be able to work with them. Generally, we'd have letters of recommendation. So if you feel that you're kind of deficient in one of these, letters of recommendation can help as well. And then, so just lastly on the admissions, so there's really 3 admissions decisions that I make. One is the rejection, just because of at some points, there's just some other deficiencies in several of these parts that may not be for this program. The next decision is a conditional acceptance. And so really what that does, it limits you to those first 2 classes, the Introduction to Systems Engineering and Management of Systems Projects. You have to get an A or a B in both of those classes before you can progress on and gain the full admittance, which is the last one, full acceptance, and then you can take the courses there. There are also some limitations there, potentially with some financial aid programs may kind of require students to be able to take 2 classes based on their financial aid requirements. Again, we work with those individuals on a case-by-case basis. Okay, so that's the generally what we're talking about in terms of admissions.
All right, thank you, Dave. In terms of application review, for our online and part-time students, we do not have, let me back up. For our online and part-time students, we offer rolling admissions. So you can submit an application and start in any of our 3 semesters, fall, spring, or summer. And because we offer rolling admissions, we do not have a hard application deadline. So what we wanted to share with you is basically the timeline it takes us to review a completed application. So you can see here on your screen, application review takes us on average about 4 to 6 weeks from when we receive a student's completed application. So that's their online application, their academic transcripts, their professional resume, 4 to 6 weeks to issue that student a decision letter. With that in mind, here are some important dates. Spring registration actually opened last week. It opened on October the 25th, and our spring semester begins on January the 28th. So if you are interested in starting in our spring 2019 semester, I encourage you to submit your application as soon as possible, ideally by mid-November.